members. This is still in section 6.3. So for zero force members, this is one of the things that'll help us with doing it by inspection. But these rules will sort of make your life a little bit easier. So we'll be smarter instead of doing harder ones. So it's a good ones to keep in mind. Basically with this, if only two members form a joint, so if only two members form a joint and no external load is applied, then both of the members are zero force members, which that's just ZFM, zero force members. The second rule is, so if the three members form a joint and two are collinear and no external load is applied, then the third member is considered to be a zero force member. You really want to look for these. They'll make your life a lot easier. I'm going to show you two pictures just to show you what I'm talking about. Visually, it may make it easier. So for the first one, if you only have two members form a joint and no external load is applied. So let's look at this truss and see which ones that works for. So if only two members form a joint, so right here there are two members, 1, 2, so DE and DC, and there's no external load applied, so then both of those members are zero force members. So this is a zero force member, and this is a zero force member. And then, let's see, that one had, at E, we've got 1, 2, 3, 4, so that doesn't work. We have 3 at C, we have 1, 2, 3, 4 at B. At A, we only have 2, and no external load. So at A, these would also be zero force members for both of those. So when we're doing the analysis, we can actually basically just get rid of those two. So that was where that joint A was. This is where that joint D was. So you can see that really simplifies it and makes it easier. So for the next rule is if three members form a joint and two are collinear and there's no external load applied, then the third member is a zero force member. So now we'll look at an example of that. So for this one, so let's look where we have three members for a joint and two are collinear. So let's look at D. So we have three members and DE and DC are in the same line. That's that collinear. Then we have a third one. And there's no external load applied. Then this member here, that DA, is just a zero force member. So we can just take that one out for the analysis. And then we have it again at joint C. We have these two members are in the same line. They're collinear. Then we have this third one. No external forces. So this one also would be a zero force member. So we can basically rewrite that joint to look like this, which you can imagine is a lot more simple. So those are good things to think of, and so that you can sort of do them by inspection, which was our third method. So for those two, for the zero force members, basically that gets into that by inspection method, which was that third method that we talked about for solving these equations. Sometimes you can do this depending on the setup, and basically it's when you can figure out the internal forces without having to take a joint or do a section cut and do the equilibrium equations. And so just make sure you keep an eye out for zero force members. And I guess the last thing for the zero force members is the reason why you would even have zero force members in a truss is basically to aid in zero force members. They help you aid in stability and any changes in load. So stability, things like buckling, and for changes in load, things like wind, cars, that sort of thing. And you've all probably seen the video of the bridge that the wind started going, it hit the natural frequency, and then it fell down. So that's the reason why you would have these zero force members, are to help with some of that stuff. So make sure you keep an eye out for those. Sorry this is such a long video, but it does a lot with trusses. So the last section for trusses is the method of sections.